All right, so talking more about areas of various shapes and figures. We have a shape here that has two bases. These triangles mean that those bases are parallel, and then we can see that we're going to have a perpendicular height between those bases. Does anybody know what this shape is called? I'm hoping that you all said it's a trapezoid. Those parallel sides are called bases. The height is the perpendicular distance between those bases. You're going to see a lot as we get deeper and deeper into this geometry that distance needs to be perpendicular when we talk about the distance between two different things. That's going to come up even more um, when we talk about distances between points and lines. But whenever we talk about distances, we're always talking about the perpendicular distance, unless it's specifically otherwise described. So trapezoids have one pair of parallel sides. They do not have to be congruent, but one pair will be parallel. The other pair, not so much. If we copy the trapezoid and then kind of slide it over and flip it over, it's what's called a glide reflection, you'll see that we have a parallelogram, where if we add up the bases, it becomes the base of the parallelogram, and the height of the trapezoid is the height of the parallelogram. So if we found the area of that entire parallelogram, it would be the sum of the bases, base 1 plus base 2, times the height, right? But our trapezoid is only half of that. So the formula for the height of a trapezoid is 1/2 the height times the sum of the bases. Again, the bases being the parallel sides, not the other two. So if we've got, this is maybe one of the silliest quote unquote real life examples I've ever seen, because no car's windshield is flat. But let's assume that this is maybe the dorkiest car ever made and its windshield is flat. Find the area of the glass used to make the windshield of this van. So you can see it's a trapezoid. We're going to assume that the top of the windshield and the bottom are parallel. That seems like a reasonable assumption. The height between them is 38. So the area is going to be 1/2 the height, or in this case 38 inches, times the sum of the bases. So 72 plus 85. So you can plug all that into your calculator all at the same time. 0.5 times 38 times 72 plus 85. Make sure those are in parentheses if you're doing this all at once. The area is going to be 2,983 inches squared. Okay. Here's another one. Amelia designed the pennant shown for her team. Find the area of the shaded portion of her team's pennant. So basically, we're looking for the area of the gray shape over here. We know that one of the bases is 10 inches. I don't know the other base, and I know that the height is going to be 4 inches. I know it's the height because it is the perpendicular distance between those bases. This 8.5, while it might be helpful to us, is not a useful measurement for finding the area. So take a minute, go ahead and pause this. Let's make this a yo-yo, or at least the start of one. Take a minute or two, pause this video, and see if you can get started. See if you can find out how we might figure out how we might find out the length of this other base over here. Okay. The key to this is changing the picture just a little bit. If we redraw it like this, as a rectangle and a triangle, that might be a little bit more helpful. Because now that I have this right triangle, I know that the base of this right triangle is 4 inches. I can use this 8.5 to find this distance. So let's do that. L squared plus 4 squared will give us 8.5 squared. So L squared is 8.5 squared minus 4 squared. So L is the square root of 8.5 squared minus 4 squared. If you're careful with parentheses, you can plug all of that in all at once. So the square root of 8.5 squared minus 4 squared in parentheses is 7.5. So I know that this is 7.5. Now you might be wondering how that's going to be helpful. Well, if that's 7.5, this entire thing is 10, right? So that means that this has to be 2.5. And if that's 2.5, this is also 2.5, because you can see that we made a rectangle. Opposite sides of a rectangle have to be the same length. So now I can jump over to the area of my parallelogram. Excuse me, of my trapezoid. Area is equal to 1/2 the height times the sum of the bases. So 1/2 the height is going to be 4. Base 1 will be the 10 inches we were given plus the 2.5 that we figured out. So the area is 1/2 of 4 is 2 times 12.5 or 25 inches squared. Okay, so a couple more definitions. A rhombus is a parallelogram. Remember, parallelogram means opposite sides are congruent and parallel, and that opposite angles are congruent. So a rhombus is a parallelogram, but all four sides are congruent. And a kite is a quadrilateral with exactly two pairs of consecutive congruent sides. So consecutive congruent sides means that the two congruent sides are next to each other as opposed to opposite each other like they would be in a parallelogram. These are both kind of special quadrilaterals. A rhombus is a special form of a parallelogram. It's got all four sides the same. It's kind of like a rhombus is to a parallelogram as a square is to a rectangle. They're kind of special cases of those other figures. A kite is similar, but instead of having opposite congruent sides, it has consecutive congruent sides. A kite will also have exactly one pair of congruent angles. It'll be those two, the angles between the pairs, not the angles within the pairs. The areas of rhombi and kites are related to their diagonals, and the formula is actually the same. The area of a rhombus or a kite is 1/2 the product of its diagonals, diagonal 1 and diagonal 2. It doesn't matter which one of those is which, but if you find the lengths of those diagonals and multiply them, cut that in half, you have the area of the rhombus or kite. Again, pause this and copy this down if you need to. I'm going to move on to the next slide. So, a couple of yo-yos, just plugging stuff in. Take 2 minutes, pause this video, and then when you come back, we'll go over it. Please do pause the video and give this a shot on your own. Okay, here we go. This diagonal is 8 meters, and the long one, the vertical one, is 15. So the area is 1/2 the product of those diagonals. So 1/2 of 8 is 4 times 15 is 60 meters squared. We have another one down here, a rhombus. This is a kite, right? In a kite, these are congruent, and these are congruent. In a rhombus, all four of these are congruent, but we have some parts of the diagonals marked congruent. So if this is 12, then this is 12, and if that's 10, then that's 10. So the area would be 1/2 20 times 24, or 10. 1/2 of 20 is 10 times 24, 240 feet squared. You didn't even need a calculator for either one of those. Hopefully you got them both. One diagonal of a rhombus is twice as long as the other diagonal. If the area of the rhombus is 169 square millimeters, what are the lengths of those diagonals? So I've got a rhombus. It looks something like this. I've got one diagonal and another one. That's not perfect. One of them is twice as long as the other. So diagonal 1 is equal to 2 times diagonal 2, let's say. I also know that the area is equal to 1/2 diagonal 1 times diagonal 2. So I have another system of equations because this is one of them. If I plug in the 169 that I was given, I have my other one. These are the two equations we're going to use to solve. If I substitute this in for diagonal 1 in the other equation, right, because 2 times d2 has to equal d1. If I plug that in there, that gives me an equation I can solve. 169 equals 1/2. d1 is now 2d1 times, 2d2 times d2. d2 is the only variable I have left. Well, the 1/2 and the 2 will cancel, so I will have 169 is equal to diagonal 2 squared. Let's take the square root of both sides. Square root of 169 is 13. So I know that diagonal 2 is 13. So if I now plug that into this equation, diagonal 1 is equal to 2 times diagonal 2, which I know is 13. Diagonal 1 is 26. So my two lengths are 26 and 13. Here's kind of a summary sheet of the 4 shapes we've discussed so far: parallelograms, triangles, trapezoids, and then rhombi and kites together. We have the formulas for area listed for each of these and a couple different pictures for each one, kind of showing the different circumstances. So parallelogram with the height inside versus the height outside the parallelogram. A triangle with the same scenario, height inside, height outside. Trapezoid, where the height is inside, and then a trapezoid where the height is actually one of the sides, and then a rhombus and a kite. This would be a great thing to make sure you have in your notes, especially on your formula sheet. So go ahead and pause this and copy whatever down that you need. Good luck with the homework, and I hope you have a great day. Reach out if you have any questions, and like I said, just pause and copy this for as long as you need.